Hi dear students, now we are going to discuss a very important title, Atmospheric Composition and its Structure. So let us see a small introduction about the spheres of Earth before entering into our title. We all know crop growth entirely depends on climatic condition or weather condition of a particular area, and the weather of a particular area depends on the atmospheric condition prevailing there. So the atmosphere, we all know what is atmosphere. The atmosphere is like an ocean of gases and is a part of earth, like land and water. As such, in agriculture it is very important to study this atmosphere because it is a continuum, soil, plant and atmospheric continuum, which makes the plants to grow. When you see the four spheres of agriculture, we call it as lithosphere, hydrosphere, biosphere and atmosphere. Lithosphere is a solid portion, hydrosphere is the liquid portion of the earth, and biosphere are us living organism, and atmosphere is the gaseous portion. So this word atmosphere, atmos and spera is derived from a Greek word which means vapor and sphere, and it is nothing but it's a mixture of gases surrounding the earth, and it is as you can see the picture. It forms like an envelope surrounding the earth's surface, and it is like a protective blanket which surrounds the earth, and the mass of the atmosphere is about 5.15 into 10 to the power of 18 kilograms. So if if there is no atmosphere covering our earth, the temperature of our earth will be around 95 degrees centigrade in the morning time, and it will be minus 145 degree in the night time. And when now let us see the composition of the atmosphere. So atmosphere, it is the mechanical mixture of gas, liquid particles and also some solid particles. We all know what are the nearly constant constituents. Those are nitrogen, oxygen, argon and carbon dioxide, which forms the 99% of gaseous mixture. And the next comes the trace constituents and highly variable constituents. Trace constituents are like neon, helium, hydrogen and all. And variable constituents of water vapor, sulfur dioxide, nitrogen dioxide. These things you would have already studied in your school days. Now comes the important part of your course, that is composition of atmosphere. So based on the concentration, our atmosphere which surrounds the earth's surface is divided into homosphere and heterosphere. This homosphere is the lower layer of the atmosphere which has uniform composition of air, whereas heterosphere is the higher level of atmosphere, and here the concentration of the gases changes. So first, for example, oxygen. So oxygen, it is very essential for the living things in the earth, and the important for respiration, and it is released by the plants during photosynthesis. And next comes the nitrogen, which is important plant nutrient, like and carbon dioxide. It is a good absorber of heat and maintains the heat balance of the earth. And if there is no we know carbon dioxide, respire back the carbon dioxide, but if there is no carbon dioxide in the earth, then the temperature of the earth will be around minus 23 degrees centigrade. So it is a very good absorber of heat. So each and every gases has a important role to play in in our earth. Now let us see the layers of the atmosphere, which is also known as stratification. We call it as stratification of atmosphere. Here there are series of concentration of layer above the ground sea level, from this ground level to for around 64,000 kilometers above the earth. So this layering of the atmosphere is done by four processes, either by composition of atmosphere or temperature variation in the atmosphere or chemical reaction that takes place in the atmosphere and ionization that takes place in the atmosphere. Out of all these four processes, the important thing which we consider for the stratification is based on the temperature variation. So depending on this, the Earth's atmosphere is divided into different layers. Those are first we lowermost layer, as you can see in the picture, the lowermost layer is the troposphere, next comes the stratosphere, next is your mesosphere, thermosphere and exosphere. So now let us see them one by one. So the first sphere we call it as troposphere. So this term tropos is a Greek word which means mixing. So mixing or turning we call it as, and this is the lowermost region of the atmosphere. So here the thickness of the atmosphere, this layer above the ground level, varies from the equator to pole. The thickness will vary. So on an average we call it we can say approximately the from the ground level to 18 kilometers above the ground level we call it as troposphere, but this thickness, as I said, will vary from the equator to poles. And it is the densest part of the atmosphere because it contains water vapor in them and also pollutants, and 85% of the total atmospheric mass occurs in this is due to this layer. And this, the lower part of this troposphere, we call it as the lower part up to, that is 1.5 to 2 kilometers, we call it as friction layer, because here the influence of the wind will be more. Also, all the weather parameters which we are experiencing, the cyclone, storm, lightning, heavy wind, snow, rain, everything occurs in this zone. That is why this zone is also known as a weather sphere or weather zone or weather making layer, or very importantly we call it as seat of weather phenomena. But the very important thing to note in this layer is temperature variation. Most of you would have gone to hilly regions, right? While climbing up a hill, we feel there is a reduction in temperature. So this temperature decrease with the increase in altitude is the important character of this layer, and we call it this as environmental lap state. This is not uniform, but it varies from region to region. So normal, when you see the normal environmental lap state, for 1 kilometer height rise in the temperature height, there will be a fall of 6.5 degrees centigrade of temperature. So and after this layer and before the next layer, that is lower layer is called troposphere, the next is the stratosphere. In between this troposphere and stratosphere, there is a layer which separate both these layers, and we call that layer as tropopause. And the meaning of tropopause is nothing in Greek, it is a Greek term which means where the mixing stops. And the temperature of the atmosphere in this tropopause region is minus 60 to minus 80 degrees centigrade. Next is stratosphere. Stratosphere, the Latin word stratum, which means layer, and this layer extends above the troposphere from 50 kilometer till 50 to 50 kilometers. This layer will extends, and it is of dust free and a very warm layer. And when this layer is extremely dry and almost there is no cloud in this found in this layer. However, clouds are formed rarely and in some regions. And but they do, this type of clouds, they do not produce any rainfall. And clouds in the stratosphere is called as mother of pearl for this reason. So 15% of the total mass of the atmosphere lies in this layer. and in this troposphere the temperature increases with the increase in altitude, whereas in troposphere as the height increases temperature decreases, but in stratosphere as height increases temperature also increases. The photochemical activity, there are a lot of photochemical activity taking place in this layer, and hence this layer is known as seat of weather phenomena. And the stratosphere, it can be divided into lower portion and upper portion. In the upper part of the stratosphere the temperature is more, because here is where absorption of UV rays starts. And in the stratosphere hot air does not rise above, because since the air above is more hot than the are found below. And the layer separating this stratosphere and next layer of mesosphere, we call it as stratopause. So the layer which is found above the stratosphere, we call it as mesosphere, and this mesosphere is also known as ozonosphere, and the Greek word meso means middle layer. So this layer, it extends from 55 kilometers to 80 kilometers above the ground level, and the maximum absorption of UV radiation occur in this layer. The maximum part of the ozone layer is in this layer, and it is the cold, and because of the absorption of UV, the temperature will be warm, and it is also the coldest layer when compared to the layers, because the temperature here sometimes it will be minus 95 degrees centigrade, and there are a lot of chemical activities happening in this layer, and because of this region, this layer is also known as chemosphere. And the layer separating this mesosphere and the above thermosphere layer is called as mesopause. The next layer comes the thermosphere. So above the mesopause, this thermosphere layer is will be there, and in this layer ionization of the atmosphere begins, and the temperature of this region will increase rapidly as the height increases, and sometimes at the height of 350 kilometers the temperature may rise up to 1200 degrees centigrade, and but the air density is very poor in this layer. And this layer is also known as ionosphere, because ionization process takes place in this layer. So in this layer is further, when you see this layer is further divided into different layers called D layer. From 80 to 100 kilometers it is called a D layer, and 100 to 130 kilometers it is called as E layer. And uh, this layer, and aurora also known as, which is very famous in the polar region, the polar lights, the aurora polaris occurs here in this region. So the final layer is the exosphere. So this exosphere is the outermost layer in the atmosphere, and above the thermosphere this layer is present, and this extends from 400 kilometers to 1000 kilometers. And this layer, helium is the major gas found, and the uppermost, when you see the uppermost layer of this exosphere, sometimes the temperature may reach above 5000 degrees centigrade. So in this layer the gases are arranged in four spherical shells, and those are nitrogen layer, oxygen, helium layer, and lastly hydrogen layer. So that's all we have in this lecture. We have seen in this session we have seen the different layers of atmosphere which is found in our atmosphere, like troposphere, the stratosphere, next comes the mesosphere, then comes the thermosphere, and finally the exosphere. Thank you.